lesson 2.2 here is standard form of a quadratic equation. So we just spent 2.1 talking about vertex form. And we basically have these two really important forms that you deal a lot with and you see a lot. Okay, vertex form was the one where it's the a times x minus h squared plus k. Okay, standard form, you probably see more, although I would argue it's maybe a little less useful, but standard form of a quadratic equation is the y equals ax squared plus bx plus c, where a, b, and c are officially real numbers, and a cannot equal 0, because if a equals 0, it's no longer an x squared equation. Okay? So that is standard form of a quadratic equation. Now, to go along with standard form, this is why, in my opinion, it's not, quite as helpful. I can't just look at ax squared plus bx plus c and be like, oh, there's my vertex. Oh, there's my axis of symmetry. So what we have is we have a formula to find our axis of symmetry. Okay? So we're going to be looking at those ABC values and using them. In order to find your axis of symmetry, you guys already know it's x equals a number, right? And it's going to be x equals, and it's negative of b over 2a. Okay, so we'll practice that. Once you know the axis of symmetry, well, what do you already know about the vertex then? If you know the axis of symmetry, you'll know the first number in the vertex, right? And so the first number of the vertex is going to be your axis of symmetry. Your y-coordinate, we're going to find by plugging in the x-coordinate, like a plug and chug. Okay, we're going to substitute the x-coordinate in, and we're going to solve to find the y-coordinate. Okay, so two important things, being able to find axis of symmetry and vertex. Okay, so we're going to look at that with standard form today. The other thing we'll talk about when it comes time, so we're going to do a little graphing if you've looked ahead, is we'll talk about finding the y-intercept. Okay, and excuse me. Thank you. We'll talk about finding the y-intercept and using that to help us graph. Okay, and again, reminder, it's still a quadratic function. Quadratic functions are parabolas, right? Old news there. So let's look at the first example here. They ask us to find the vertex of this function. Okay? If it was in that vertex form from yesterday, I'd be able to see how far left and right it goes, how far up and down it goes. And I could use that. But it's not in that form. So we have to have a plan B. Hello? You surely can. You're welcome. Phone call. Children. Okay, so in order to find the vertex, based on what I just kind of said, what are we going to have to know besides the vertex? We're going to have to know the axis of symmetry, right? So first thing I'm going to have you do, I like to identify my ABCs. Okay? So with that in mind, keep in mind this is of the form ax squared plus bx plus c. Okay? Can you tell me your ABCs? What's a going to be? 1. It's the number in front of x squared, the coefficient in front of x squared, or in this case, it's the invisible number in front of x squared. So a is 1. And yes, I write these down. You may not feel the need to write these down, but as the teacher, our very first example, yes, I'm going to write them down. What's b? Negative 6. It's the coefficient of the x term. So it's negative 6. And what's c? C is 10. It is the constant added or subtracted at the end, right? Okay, so as I said, I like to go through and identify my ABCs. Now that I know my ABCs, before we can find vertex, guess what we have to find? Axis of symmetry. So we're going to go through and find our axis of symmetry. In order to find that axis of symmetry, how do we find axis of symmetry? Handy dandy little formula, yes? So we're going to use x equals the negative of b over 2a. What do you know? Negative of b, and officially, if you look at this, the negative is in front of the fraction. I tend to just put it on the b because it goes either with the top or the bottom, not both, okay? Or just goes out in front of the fraction. I tend to just put it on the b. So if we're doing the negative of b, what's that mean? It's the negative of negative 6. What do I mean by the negative of negative 6? That's going to be positive 6, yes? I could also say the opposite of negative 6 is going to be positive 6. Over 2a, so that means I'm going to do 2 times 1. So the opposite of negative 6 is 6. 2 times 1 is 2. And what's 6 divided by 2? 3. So right there, you have found your axis of symmetry. X equals 3. Am I done? No. They asked me to find the vertex. So now, if I'm talking vertex, what do I know currently about this vertex? 3 is my h. 3 is my x value, whichever way you want to think about it. So if I had to give my vertex right now, I can get partial credit and say 3 comma something. That's what I know. Okay? That's what I know because I found my axis of symmetry. Now, how do I find the y value? We were given an equation, yes? Use it. Yep. Put that 3 back into x. Plug and chug if you like. So, y equals, and I'll write this out, but x squared minus 6x plus 10. We're plugging in there. So y equals 3 squared minus 6 times 3 plus 10. Okay? Do those exponents and that multiplying before we add or subtract. 3 squared is 9 minus 6 times 3 is 18 plus 10. 9 minus 18 plus 10. 9 minus 18 is negative 9 plus 10 is 1. So I just found y to be 1. What do we know then? That's the second number of my vertex. And my vertex is the ordered pair 3, 1. Okay? This is a skill you would have learned back in Algebra 1. Did I say you remembered it? Not at all. I think quadratics are a really foggy part of Algebra 1 just because you don't really talk about quadratics in geometry. So I think, well, a lot of the stuff we're doing in this chapter, or you've done before, I don't guarantee, some of it you're not going to remember. Okay. Do you know enough to do the next problem? Okay, let's do it. Find the vertex. I am going slightly off the screen here. Not much, but okay. Find the vertex. Remember, notice what form they gave it to us in. Y equals ax squared plus bx plus c, right? This is standard form. Write down your ABCs. Don't write down your ABCs. Your call, right? I'm going to write them down because I'm the teacher. My A value is 2 because it's in front of the x squared. It's the coefficient of the x squared. B value is -8. It's the coefficient of the x term. And C value is 5. It's a number that has no x's with it. It has, it's a constant. Okay. What are you finding first? Yeah, we've got to find our x, which means I'm finding my axis of symmetry. X equals, what's that formula? Negative of b over 2a. Okay. Henry.
Hello, when that happened.
Last problem. I saw it fly away. Okay. Now, this formula, folks. Are you hopefully going to use it enough that you have it memorized? Probably. Now, in all honesty, you're going to get a formula sheet at the end of this chapter. Okay? So if you want me to be honest, do you have to have it memorized? Technically, no. But you're going to use it enough. It's hopefully going to get stuck up in there. So, okay, axis of symmetry. Negative b over 2a. So what am I doing? Again, b is negative. I seem to like doing that. The negative of -8 over 2 times a, 2 times 2. Opposite of -8 is +8. 2 times 2 is 4. And 8 divided by 4 is 2. So I have an axis of symmetry of x equals 2. If they ask for it, great. If they don't ask for it, well, we still had to find it. Okay? After you find your axis of symmetry, you're going to find your vertex. If you had to get, what can you tell me about your vertex right now if you had to give it to me? My x is 2. Bless you. So 2 comma something. How do we find the rest of that vertex? Plug and chug, yes. Take the 2, plug it into the equation. Okay, I'm going to need all that space there. I'm kind of running out of space. Okay, so we're using the equation. 2x squared minus 8x plus 5. Let's talk about how to do this 2x squared. Well, yes, you should know. Do we remember? Yeah, I don't know. So 2x squared is 2 times 2 squared minus 8 times 2 plus 5. Now, 2x squared, 2 times 2 squared, means we do what first? First thing you have to do is the 2 squared. What is 2 squared? 4. And then take the 4 and multiply by 2. So we end up with 8 minus 16 plus 5. Okay? The common mistake there is to do 2 times 2 is 4 and then do 4 squared. But that gets you a much bigger answer. So be careful. Let's see. 8 minus 16 is -8 plus 5 is -3. Fill that in, and I know my vertex is 2 comma -3. Okay. You got the basics. Okay, this is just our other way to find axis of symmetry and vertex given a different form of the equation. Now, hopefully you're not surprised. What do we have to use this information to do? Graph. Okay. So this is our next plan, is using our information to graph. So first of all, I can notice that again, is this in standard form? Yeah, again, this is in my y equals ax squared plus bx plus c form. Okay? Are you going to get tired of that form? It's all day today. With that in mind, can you humor me and tell me your ABCs? What's A? 1, the invisible number in front of x squared. What's B? -4, it's the number in front of x. And what's C? 8. I'll say it again. Do you have to write out your ABCs? No. Okay, that's a teacher thing in me. If I was doing this on my own, would I write out my ABCs? No way. Unless I'm making an answer key for you guys, then I'm going to write out my ABCs. Okay? But I want to make sure we all know what we're talking about. Okay, guys. In order to graph this, what do we have to know to graph a parabola? We're going to have to know the vertex. So if we're going to have to know the vertex, what are we going to have to find first? Axis of symmetry. Am I redoing the same thing I just did up above? I am. Okay, so let's practice. Let's find our axis. X equals, you got that formula memorized yet? Negative of b over 2a. Again, I did it again. I made b negative. Realize if b was already positive, then the negative would change it to a negative, yes? I just have to, we're doing the negative of -4. So it's going to become positive 4 over 2a, so 2 times 1. 4 over 2, which is 2. So we have an axis of symmetry of x equals 2. Okay. Once you know the axis, you can find the vertex. If I asked you the vertex right now, what do you know? It's 2 something, right? Okay, I automatically know that. How do I find something? Okay, we're going to plug it in. So, y equals, I'm plugging it into the original, yes. 2 squared minus 4 times 2 plus 8. 2 squared is 4 minus 4 times 2, so minus 8 plus 8. 4 minus 8 plus 8. Well, minus 8 plus 8 is going to be 0, so we're left with 4. Okay? So we have a vertex of 2, 4. Okay? I didn't draw the lines that time. Do I need to? Should be getting to be same old by now, right? Now, before I graph this, you're going to need at least one more point. Okay, you can't just, I don't just want a vertex, and then you just like, oh, it's a U, and just draw your random U. We need at least one more set of points to go through. Okay, I'm not going to say you have to have like 5 total points, but if you know your vertex and at least one other point, then we can find a pair and we can make that work. An easy way in this problem, it's not the only way, but an easy option is to talk about your y-intercept. Okay, so let's talk about the y-intercept for a moment. Kind of running out of room here. Your y-intercept. I don't know how much you guys remember. This was in lesson 1. Do you guys remember officially how to find y-intercepts? I have a shortcut here, but No. 0 and for x, right? Y-intercepts happen when x is 0. So if you take 0 and plug it in, look at what happens. You have 0 squared minus 4 times 0 plus 8. So, well, 0 squared is 0. 4 times 0 is 0. What are we left with? 8. Okay. Now, the shortcut on this, folks, 8, if you notice, is your... Okay. Oh, no. Okay. 8, if you notice, is your C value. Yes? It's a number that, in this problem, that does not have an x attached to it. It is your C value. Well, guys, the shortcut for y-intercept, your y-intercept is always your C value. You don't have to plug in 0 every time. You can just be like, oh, there's my C value, that's going to be my y-intercept. That's where this graph is going to cross the y-axis, okay? So just a friendly little reminder there. Now, as an ordered pair, my y-intercept is 0, 8. And we'll look at what that looks like here in a moment. Now, keep in mind, if you know a point on one side of your parabola, what do you automatically also know? Do you know the point on the other side? These parabolas are what we call symmetric, yes? So if you know a point on one side, you're going to know a point on the other side. So what I say about the y-intercept is we use the y-intercept, and then we're going to reflect to get its partner. Okay? And I'm going to walk you through this. But those are kind of the steps I have us think about. Now, okay, guys, ready to do some graphing here? First thing we found was the axis of symmetry. Okay, I've been bad this week. I haven't been in Savas to check and see how the directions go in each section lately. I'm going to put it on here because it's in my notes. How do we draw on an axis of symmetry, x equals 2? On the x-axis, we're going to find 2, and what do we draw? Okay, it is that dotted line. It's not actually part of the graph, but it's a dotted line, and it represents the axis of symmetry. It represents the center of where my parabola is going to be symmetric. Okay, you had to put the axis of symmetry in one other time this year, didn't you? Because I know it caught some of us, me included, on the graph because I forgot about it. Okay, so be aware it might ask you for the axis of symmetry in this homework, okay? Just be aware. Now, there's my axis of symmetry. Where's my vertex supposed to be? 2, 4. Well, let's check this out. If I go right 2, up 4. Notice, where did my vertex land? It landed on my axis of symmetry, yes? Okay, vertex landed on the axis of symmetry, so that's good. And then I said, I do not want you to just go, oh, there we go. No, don't do that. Okay? I want at least one other point. Now, one option is, there's a y-intercept here, yes? Where is a y-intercept of 8? On the y-axis, you're going to go up 8. Okay, I'm going to go up 8 here. Now, think with me. If my vertex is here, I have a y-intercept at 8. Where is an equivalent point? Where is my reflected point? This 8 is where? It's 2 to the left of the axis of symmetry, so where should I have an equivalent point? 2 to the right of the axis of symmetry. So at 4, 8. Now, is that officially enough points? I'll take it for this. Okay, if they ask you to do axis of symmetry, and vertex. If you find one other point, I'll take it. Now, I said y-intercept is what I want to focus on, okay? And that's good. There is one other way I could think about it on this problem. It doesn't always work. What was my a value? My a value was 1, yes? My a value won't always be 1, so this option won't work, always. But if my a value is 1, what do we know about a basic y equals x squared parabola? It does what? Over 1 up 1, over 2 up 4. Could that also help give me points here? Okay. Now, in Savas, if they specifically say we want the y-intercept, then you have to graph that. But if they don't specifically say, does this make sense? I'm not going to make those big and bold, but over 1 up 1. And think about it where it's over 2 up 4. Oh, hey, did we already have over 2 up 4? Yes. Okay. So when it comes to paper pencil time, I'm trying to give you some options, some way to help check yourself. Okay, so yes, I put the points that are over 1 up 1, but you wouldn't have to have those as long as you have your other points there. Okay, questions? Okay, well, let's keep moving to the back side. We're going to practice graphing another one. Anything strike you as you look at this equation? Huh? Okay, they're all negative. Specifically, the negative I want to talk about is the first number's negative. What's that tell me if x squared is negative? We're going to be upside down, aren't we? Okay, just helpful to recognize that. Okay, guys, so I'm going to write down my ABCs because I'm the teacher. A is -1, B is -6, C is -1. I promise B is not always negative, just for whatever reason that is in my examples today. Axis of symmetry. That formula is x equals negative of b over 2a. The negative of -6, or the opposite of -6, over 2 times a, 2 times -1. The negative of -6 is positive 6. 2 times -1, -2. 6 divided by -2, -3. Bless you. Axis of symmetry is x equals -3. Once you find the axis of symmetry, you're finding the vertex. What do I already know about my vertex? I know there's a -3. Take -3 and plug it in. Now, we're going to have to be careful with this x squared. It's the negative of x squared. So the negative of -3 squared minus 6 times -3 minus 1. Now, what is -3 squared? -3 times -3 is 9. What is the negative of 9 then? -9. Okay, so you save that negative on the outside for the end. You square the x value, then we make it negative. Minus 6 times negative 3. I think of that as negative times negative, so I think of this as plus 18 minus 1. Negative 9 plus 18 is 9 minus 1 is 8. So I have a vertex of negative 3, 8. Now, okay, if you notice, my a value is a negative 1, right? Technically, what do we know about the shape of that parabola? It's going to be, instead of going up, it's going to go down, but it's going to go over 1, down 1, over 2, down 4, yes? Are they all going to do that, though? No. What's my other option? Find the y-intercept. Okay? Now, I say find the y-intercept. What's the y-intercept? Negative 1, because what is it always? It's always your C. Okay? If you don't like that, okay, plug in the negative of 0 squared minus 6 times 0 minus 1. That's the long way if you ask me, because it's always going to be your C value. So y-intercept is going to be 0, negative 1. I'm going to use that, and I'm going to reflect it. Okay? Okay, we're ready to graph this? How do I graph my axis of symmetry? X equals negative 3, so on the x-axis, I'm going to go to negative 3. And it is that vertical dotted line. It would not surprise me at all if you have to graph the axis of symmetry today. So just beware. Vertex. Vertex is negative 3, 8. If your vertex is not on your axis of symmetry, I don't know what you're doing. Okay? Vertex has to be on axis of symmetry. It's the only thing that's logical there. Now, y-intercept. I'm going to use the y-intercept. Y-intercept is supposed to be what? Negative 1. So on the y-axis, negative 1. Does it make sense that it's way down there? Could that happen? Well, we already talked. What's this parabola supposed to be doing? It is supposed to be upside down. Now, okay, make this guy symmetric. If this point is 3 to the right of my axis of symmetry, where's the equivalent point? There's an equivalent point 3 to the left. Okay? And that, folks, is technically good enough. I know it's going to make it a little bit harder to draw a nice parabola, but that's technically good enough. You could use, because it was 1x squared again, you could use the over 1 down 1, over 2 down 4. Now, we don't usually talk past over 2 down 4. What would be the next set after 2, 4? What is 3 squared? 9. So the next set, we do 1, 1, 2, 4. 3, 9 would be your next set. Guess what? Over 3 down 9, guess where those points land? Right there. Okay? Kind of missed the important dot there. Okay. I'm going to stop there. I could push and say, let's try and get through a word problem, but I don't think it's going to happen, especially because we're going to have to grab calculators and whatnot. So here's the deal. I'm going to readjust my lesson plans for next week and figure out exactly how I want to proceed. For whatever reason, I was supposed to get all the way through this page today. I'm not sure how. Maybe I didn't do the second word problem example. Maybe that's what it was. I don't know. So I'm going to readjust. Now, is Savas homework out there and available? Yes. And as of right now, it says due on Monday. Am I going to make it still due on Monday? No. I will get into Savas, maybe during homeroom if I get a chance, and adjust the due date. Okay, so just kind of beware. Okay, that also means part 2 will bump a little bit. I don't know. So Monday, I will definitely teach this. Honestly, I may go ahead and teach part 2 also, but then bump out due dates type thing. I don't know. We'll see. I'll figure out a plan. Okay? So, no homework due Monday, but you can start working on it. You're not caught up in other Savas. Get it done.